All right, so this is a picture from my vacation, and this is just outside of Haiti. That would have been bad. All right, so here we go. So I'm at the top of the Dragon's Breath zip line, and this is my daughter and my niece and my nephew, and or my other niece, my nephew, and my son. And so they taught us how to torpedo, and that was a very big deal with them. They wanted to make sure that we knew how to torpedo and to get into torpedo position and stay there long enough. And I kept thinking, I wonder why they're so worried about being in torpedo mode. So in torpedo mode, you're basically lean back, your hands are close to your chest, your feet are straight out, and you're making yourself as aerodynamic as possible. So why do you think that they wanted us to be in torpedo mode? To go faster, exactly, to make sure that we got to the end. So then they said, okay, we want you to count the orange or the yellow balls on the way down, and we want you to make sure that you get past the sixth one before you move out of torpedo mode and into landing mode. Okay? And so when we were heading down, that's them going further down. You can now see the yellow balls, right? And they're landing on this platform clear down at the bottom. So this is the longest, supposedly in the world, over water, over open water zip line. And so that's where they're getting ready to land. That's the platform. It's about 10, 11 feet above sea level. So if you don't torpedo long enough, this isn't my photo, but this is one that was on the internet, this is what happens. You get stuck. And then they have to stop everything, and they have to snag you and haul you back to the landing platform. Okay, that would be bad. Hopefully you can torpedo long enough. All right, so here's a picture of my niece actually taking a picture as well. But you can see the platform up here. This platform, according to the Royal Caribbean Cruise Line, is 500 feet above the ground, or above the sea level. And the actual line is 2,600 feet. Okay? And we want to figure out what kind of an angle of depression that line has, so we can have an idea of why they have to have us in torpedo mode for so long. Does that make sense? So if we're clear up here at the top of this hill, and it's 500 feet above sea level, and our zip line goes clear over here, and I didn't have a long enough angle on my camera, but it goes over like so. So if I have this kind of a drawing, and this is 2,600 feet, we're trying to figure out what is the angle of elevation, or the angle of depression. Because remember, the angle of elevation and the angle of depression are the same thing. Okay? So do we know enough trigonometry to be able to answer that question? I think we're close. We have the hypotenuse, and we have an angle, and is this the opposite or the adjacent to that angle? This is the opposite. So if we have the opposite and we have the hypotenuse, which part of the trig functions are we using? The sine. We are saying that the sine of the angle is equal to the opposite over the hypotenuse. So how does this look different than what we were doing on Friday? The x is in a weird place, isn't it? It's not one of the sides. Okay, this time it's the angle. Okay, so how are we going to approach that? How are we going to find out what angle is going to give us a ratio of 500 over 2,600 for opposite over hypotenuse? We're going to divide them. So 500 divided by 2,600 is what? 0.192 to 4 decimal places is probably good enough, right? Okay. So if the sine of x is equal to 0.1922, how do you think we're going to get our x back? Do the opposite of sine, exactly. Okay, just like when we have x squared equals 35 and we want to get x back, right? We do the opposite of squaring. The inverse of squaring is square root. So we would take the square root, okay? And if we had something like 3x equals 7 and we want to get the x by itself and it's being multiplied, we do the opposite of multiplication, which is division. That's the inverse function for multiplication. So the same thing applies here. If we want to find out what x is, we're going to have to take the inverse sine of the sine. And if we do that to the left side, we have to do it to the right side. Okay, so just as your calculator has all of this table of all these decimal points of these ratios of opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, and so on, right? It has the angles back. You can get them back by using the inverse sine button. Make sense? Okay, so on your calculator, let's find that. They look like this. Everybody see them? Okay, so we said that the sine of the angle is equal to the opposite divided by the hypotenuse. And we had divided it out, didn't we? But we want to take the inverse sine of the sine of x to get plain old x back. And we're taking the inverse sine of that 500 divided by 2,600. It looks like a -1, but it's not a -1 power. It's the notation inverse sine. It's the opposite of taking the sine. And so it looks like this on your calculator. And you may have to use the second or the shift button to get there. Okay? Do you have a second or do you have a shift? Shift. Okay, so we're going to take the shift, and then we're going to say of sine to get the sine inverse, and then we're going to do 500 divided by 2,600, and then enter. And what did we get? 11.008. So let's just call it 11.1 degrees. One decimal place is good enough. Now think of how tiny an 11-degree angle is. Does it make sense that that could be why they need you to be in torpedo mode? They don't have a lot of drop over that long course of run. Okay, so they would either need to have a higher hill, right? So you wouldn't have to go torpedo mode, or they'd have to shorten up their line, and they want to be the longest zip line over water, so they ask you to go into torpedo mode. Make sense? And if you don't weigh enough, you don't get to go at all because you don't make it to the bottom. I don't remember, but my son was 7 at the time, and he didn't weigh enough. So they said, sorry, you don't get to ride. Okay? You can weigh too much. My husband was close. Yes, he almost didn't get to go. Okay, so now we want to talk about angles A, B, and C. So they're acute angles now, which means that we can use sine, cosine, and tangent with them. And we want to use the calculator to approximate the measures of angle A, B, and C when they have these for their ratios. Okay? So if the tangent of A is equal to 3.29, how do we get the A all by itself? The tan inverse, right? The inverse tangent. Okay? So we want to take the inverse tangent of the left side to get the A all by itself. These guys cancel each other out. We get a plain old A. But if we do that to the left side, we have to do it to the right side. So inverse tangent of 3.29. So everybody plug it into your calculator. And what is the measure of angle A? 73.1. Everybody agree with Jadine? Anybody need more time or not know how to do it? Okay. Exactly. Your shift or second, if your calculator has a second, tangent, and then 3.29, because that gets us our inverse tangent. And did you get 73.1? Okay. Let me bring up my little graphing calculator here. All right, so move this out of the way for a moment. Okay, so we want to use the shift or the second, depending on which one you have on your calculator. And first of all, I have to make sure that my calculator is in the right mode. Get rid of my pen for just a second here. Hold on one second. Delete that. Sorry, it doesn't like to be in this mode. All right, so let me go back here and get down to degree mode. Okay. So we want to do the second or shift of the tangent. So when I press the second button and then I press the tan, that's just taking me up here to the inverse tangent piece. Okay, it'll say tan -1 or tan inverse. And then I just type 3.29. And I don't have to close the parentheses because I'm not performing any other operations, so I just press enter and we get 73.1 degrees. It should. You should get something. Okay. So far, so good. Everybody get 73.1 degrees. Okay. So let me turn my magnifier off. All right. So what do you think? Which button do you think we're going to use to find the inverse sine of? Yeah, second sine, and then 0.55. And what'd you get? 33.36, so we'll round that to one decimal place, 33.4. Everybody get that? Okay, so this one was 33.4. Let me get rid of this. All right, what did you get when you used the... Okay, now we want to find the angle C's measure, right? But the cosine of C is 0.87, so what are we going to do? Second or shift cosine, right, of 0.87. Exactly. Everybody get 29.5 degrees? All right, so we know how to use these buttons on our calculator, right? Okay, so here's our next example. Find it on your sheet. Yes, sir. Not at the moment. All right, so now we want to find the measure of angle A. Okay, so in order to find the measure of angle A, we have to know two pieces of information. So first of all, this is the angle we're after. Okay, do we have the hypotenuse? No, so always locate your hypotenuse so you're not going to be confused by whether something's adjacent or the hypotenuse. Okay, so how is the 3 related to angle A? It's opposite. How is the 5 related to angle A? It's adjacent. So when we have opposite and adjacent and we're trying to find our angle, we're going to use the TOA, the tangent. So the tangent of the angle, and this time we don't have an angle measure, right? We're trying to find it. The tangent of the angle is equal to the opposite divided by the adjacent, which is 0.6. Okay? How do we solve that for angle A? Actually, absolutely. We take the second tan, the inverse tangent of both sides. So the inverse tangent of 0.6 will be the measure of angle A. And what do we get? Everybody get 31? 30.96 is 31 degrees. All right, we're feeling good? Okay, makes sense? Any questions on this one? All right, we're moving. Sorry, a couple seconds. Apologies. All right, So next we're going to be asked to solve a triangle. Okay, when you see the word solve, that means we want to know everything there is to know about this triangle. Okay, we're saving paper. We're not making a whole bunch of little problems. We have one big problem. Okay, so that means that we need to know the measure of angle A. We need to know the measure of angle B. Everybody knows the measure of angle C at this point in their geometry career is 90 degrees, right? So you don't have to write that down for me. Okay, and then we need to know the missing side in this case. So we need to know what's the measure of BC. And if you want to call that X instead and you label your drawing X, that's fine. Okay? All right, so there are three things that we need to know because we know one angle and two sides right now. We need to find the other two sides and the other two angles on the other side. Okay? All right, so Austin, which of these three do we want to find first? It doesn't matter. B. Okay, we're going to find the measure of angle B first. Okay? So, angle B is up here. And remember, what's opposite and adjacent for angle B is different than what's opposite and adjacent for angle A. Okay? So, what is the 25 on your triangle? Hypotenuse. So that's not going to change. It's always going to be the hypotenuse on this triangle. Okay? And how is the 24 related to angle B? It is opposite. Okay? So this is opposite. We have the hypotenuse. Which of the SOHCAHTOA are we using? The sine. The sine of angle B, it's always sine with the angle, is equal to the opposite divided by the hypotenuse. We want to get angle B back, and we're taking the sine of it. So how do we get rid of the sine? Divide and take the inverse sine. So when you take the inverse sine of 24 divided by 25, what do we get? Everybody get 73.7? Okay. Now, we need to figure out next what is the A, okay, if you choose to do A, okay? So now that we know that this is 73.7 degrees, do we have to use SOHCAHTOA to find the other angle? Why not? Exactly, we have 180 degrees total. 90 is being used up. So what is 90 minus 73.7? 16.3. Could we have used the adjacent and the hypotenuse, so the cosine to find angle A? Absolutely, right? But we don't have to. So there's lots of ways that you can solve this. Okay? So then we have to find the distance between B and C. Okay, how are we going to find this X? We could use the opposite and the adjacent thing, right? Only in this case, since we have 73.7, how is this guy related to the 73.7? Adjacent. So we could use the opposite and use the tangent, right? Or we could use the hypotenuse, adjacent and hypotenuse. We could use the cosine. Okay? Do you want to use the cosine or the tangent? Okay, I like tangent better because we'll have a nicer number to work with. Actually, I like cosine better. You want me? I'll show you why. Okay? If we're using cosine, the cosine of the 73.7 is equal to the adjacent over the hypotenuse. Right? But watch what happens when we do tangent. Tangent of 73.7 is the opposite divided by the adjacent. You see how this one's nicer? because we just multiply by 25 and we have our answer. Whereas this one, we have to multiply by x and then divide by the tangent of 73.3. Okay, so there's lots of ways to solve these. You and the person next to you may not use the same path, but you still get to the same destination. Okay, so what does x end up being? Yep, because when 25 is taken times the cosine of 73, we end up with 7. There was a third way that you could have found that side. Because we had one leg and a hypotenuse, right? So we could have used Pythagorean theorem, a squared plus b squared equals c squared. X squared plus the 24 squared is the hypotenuse squared. So 3 ways to find that one value. Does that make sense? You choose whichever one works best for you, but I would practice Pythagorean theorem every once in a while. I'd practice my SOHCAHTOA stuff. Thumbs up? Okay. Do we need to see another example? Okay. I have another example, but if we don't need to see it, that's okay. I'll give you the assignment, which is a worksheet. Okay. Anybody want to see this one? All right. I think you want time to work. Let's do that.